to you all. And my first remark, please mute your mics so we don't have a mess here talking with now 89 people. So welcome to this webinar on behalf of IDF and of ICAR, especially for the action team on the reference system for somatic cell counting. I'm Christian Baumgartner, and I'm happy to chair this webinar, this session. It is a great honor to be chosen by my colleagues. Thank you. This webinar is about certified reference material for somatic cell count. And indeed, this topic or this material is a part of a large project which was carried out or is still carried out jointly with IDF and ICAR. And the overall frame for that is, as I said, the reference system for somatic cell counting. And yesterday or the day before, I looked into my files, and indeed in 2005, we started to discuss this project and this topic. And then 2008, there was an IDF bulletin about this issue. And now 7 newsletters are published for that. You will find it on the IDF or ICAR website. So today, we cannot have too much background on the whole project. Today, the focus is on this, I think, groundbreaking new reference material for somatic cell counting in milk. This material, which is long-lasting, could serve as an anchor for worldwide somatic cell counting. And this indeed is a target to reach this goal, to harmonize and make in the end all somatic cell counting equivalent in all countries of this world. And maybe beyond, the Chinese colleagues are starting to go to the moon. I guess the material could be also processed on the moon. The implication of this is obvious. So of course, somatic cell counting is a parameter for payment schemes all over the world, and also for food hygiene regulations. And on the other side, and this is then the ICAR world, of course, it's an important parameter for herd testing, an indirect parameter for, assessing the udder health of cows. And of course, it's an important parameter for breeding schemes. So this webinar is intended to give basic information about this new material, and of course, as well, trigger the discussion about this material, and in the end, also trigger the use of this material on a worldwide scale. For me, the most important and also the most valuable aspect of this all is that now we have a scientific-based anchor to anchor the somatic cell counting all over the world on a joint, on a even level. And this indeed is a very large achievement, I think. But now I don't want to take too much time. I have some announcements for housekeeping rules. So I see you all muted your mics, and please turn off your cam for the sake of sufficient bandwidth of our connection. If you have questions or remarks, you can use the chat function. I think most of you are acquainted to this function. And another indication, this webinar will be recorded and then made available on the ICAR website and as well on the IDF website, as well as the slides presented by our 3 speakers today. So that was my part to greet you. Now we have more than 100 participants, so we are ready to start. And I don't want to make too many words about our distinguished presenters. You can find more in the program of this webinar. And as a first speaker, I may invite Reinhard Seleni from the Joint Research Center of the European Commission in Kiel to give his presentation and to tell us about how this material was produced and yeah, the whole procedure behind it. Reinhard, please.
Thank you so much, Christian. I hope everybody can hear me loud and clear. Welcome from my side. I'm Reinhard Seleni, as Christian already announced. I'm working from home at the moment, from the Flemish countryside, and I will share my screen. Okay, so I would like to report on the development and production of certified reference material for somatic cell count in milk. This was basically a two-tier approach. First, we had to carry out a so-called feasibility study in order to evaluate some very important issues for a CRM, and the second part was then the CRM project. So in the feasibility study, which took by the way, longer than the CRM project itself, and which was a lot of work, we had to elaborate on these issues. How can we effectively and efficiently enrich somatic cells from raw milk? So it was very clear from the beginning that we wanted to use authentic blood, white blood cells and not beads or something. Then the next big question was, how can we stabilize reference materials apart from the current procedure, which is basically adding an additive which keeps the milk stable in the fridge for a few weeks. Upscaling was a very big issue, and commutability is a very important property of any kind of reference material, because you would like ideally to have a reference material which behaves exactly or at least very similarly to a real sample. So for the cell enrichment, we basically evaluated two methods. One is based on microfiltration. You use a 5-micron ceramic membrane on which you basically filter out the cells from the milk. You resuspend them afterwards down to the desired concentration. And the other procedure is a gravity separation, followed by a centrifugation, where you basically separate the fat from the cells and you then resuspend the cells in the milk. Both are working in principle on a lab scale basis. Microfiltration, however, is much more efficient and can be better reproducible. The next part was that we tried out freeze drying or spray drying as the two means to stabilize the material. Both are technically feasible, we found out, although the processes are very different. The freeze drying is much slower. It takes a few days when you do it properly. The critical part is the freezing, because theoretically the cells could be impaired by freezing and the way you freeze. Spray drying, on the other hand side, is a quick process. It takes half an hour and 1 hour in total. Cells are, however, exposed to high temperature for a short period of time, so that could be a potential technical bottleneck. Upscaling, I started doing the first batch in 2015, starting with about 30 liters of milk at EC JRC, and then we ended up with 2 liters of a reference material solution. That was a piece of cake, you could see. If you want to do this with thousands of units, and this was the clear goal of the project, we had to conclude that freeze drying, even though we have a 600,000 euro freeze dryer, which is really large industrial scale, is not big enough to freeze dry everything in one go. And therefore we wanted to avoid a batch-to-batch variability. Spray drying, on the other hand side, is only possible outside JRC. We don't have the appliances, but this is regularly done to produce large amounts of milk powder. And last but not least, commutability, as already said, very important. We started from raw cow's milk, so that's basically identical to a real sample. We designed a process to minimize the disruption of the cells as much as possible. We found out that defatting of the milk did not impair the results the laboratories obtained using either of the two methods. And it also has the advantage that defatted milk can be easier reconstituted and can be shows a longer life stability of the material, because you have no issues with oxidation and rancidness of the material. And we could also indirectly show that freeze drying and spray drying did not impair the integrity of the cells. How did we do it? We prepared the different reference materials and a raw cow milk sample, gave them to different labs, and they all found comparable results for a given sample. So then it was time to start the process of the CRMs. We decided to make two. one material at the low end at 50,000 cells per mil and one at the high end with 1 million cells per mil. It was outcontracted to Niso Food Research, a company in Ede, close to Wageningen in the Netherlands. So what did they do? They first pasteurized the incoming milk, then they applied cream separation to get rid of most of the fat. Then the cells were enriched on a big ceramic microfiltration membrane. The fractions were evaporated in order to concentrate them. Spray drying happened in a large spray drying tower. And then the various fractions, the fraction without cells and the fraction with a high level of cells, was then dry mixed with a special dry mixer down to the desired concentration levels. And then the bulk material was shipped to us. Just to give you a flavor, the starting amount was 13 cubic meters of milk. So that was also a reason why we could have never done this at the Kiel site. So the final processing steps, homogenization, bottling, labeling, was done by us. We used a three-dimensional mixer, filled the powders into amber glass vials to protect them from light, basically, filled them under inert gas atmosphere in a glove box. I will show that on the next slide. And then we packaged them in sets of 2. And the material code in the end was ERM, which stands for European Reference Material BD001. So these are impressions from the processing at EC JRC. So these are about 60 kilos of milk powder that we obtained from Niso. They were put for 1 hour in a three-dimensional mixer. This is the preparation of thousands of bottles. They were labeled with this labeling device. Then we use this glove box. The white tube is basically the connection to the argon pipe. And these were the poor and very well-performing ladies filling 7,000 bottles manually by hand. So it took about 5 or 6 weeks. Afterwards, all the bottles were cleaned from the outside. What you see here are the final materials. On the left-hand side, the low count, on the right-hand side, the high count material. And one reference material, as you can purchase it, contains of 1 bottle of low and 1 bottle of high in an aluminum sachet. So the next step was very important, as would be the case for any kind of reference material. You need to check for suitable homogeneity and stability. I will make it very short to have more time for the characterization. So we outcontracted this work to a Belgium laboratory having the routine method under ISO 17025 accreditation. The study design was by me. I also did technical and statistical scrutiny of the obtained results, and I calculated the uncertainty contributions related to potential inhomogeneity and instability. And the whole certification report can be found with this link. Now I jump directly to the characterization. I have seen a few minutes ago the names of quite some participants, and they were very familiar to me because basically you participated in these studies, not all of you, but quite some of you. So these were the study layouts that I conveyed to the participants before shipping the samples. Some of you use the reference method. For those, I prescribed that for the low count material, you take 3 grams out of the about 14 grams per bottle you reconstitute according to a procedure that I provided. You prepared 2 smears per slide, and then you counted the smears independently. And you did this twice per day. For the high count material, basically you did the same, but in addition, before doing the smear preparation, you made a dilution 1/3 in order to bring the SCC level down to a concentration level which is in a better working range for this method. And on a second day, the whole thing had to be repeated. For those of you applying flow cytometry methods, it was even easier. So for the low count material, the same procedure, 3 grams reconstitution measurements, 3 times per day, same for the high count material. And on the second day, the whole exercise was repeated. So in the end, I had 32 physical labs from 16 European and 5 non-European countries. Most of the European were EU countries, and the 5 non-European were United States, Canada, Israel, Argentina, and New Zealand. I had labs from basically all different heads, such as secondary RM producers, laboratory for milk payment and milk recording. So basically high throughput laboratories. We had national reference labs for milk and milk products from the European network. We had public institutions. We had the 3 big instrument providers. and we also had research institutes. And together with the samples, I provided a reconstitution protocol to make sure that everybody does it the same way. There were two protocols to choose, A and B, and they were equivalent. That was checked by me on beforehand. I provided a detailed instruction sheet of what exactly needs to be done, both the graphics that I just showed and some text. I also requested a filled-in method questionnaire where the lab should basically pretty much in detail describe the method. Which microscope do you use? Which magnification? Which flow cytometer do you use? Do you perform a recalibration? If yes, which reference material do you use? What quality assurance measures do you take? Do you check the carryover effect? So a lot of questions, and this is also reported in the certification report in the annex. So in the end, I obtained 19 reference method data and 42 routine method data sets per material. So that means 61 data sets times 2 material, 102 individual data sets of 6 to 8 individual data. So I had to evaluate about 700 to 800 individual data. So this is an example of the outcome. So the high count material, only the routine method results. What you see here in different colors are, for example, red points, only one luckily. This is a technical outlier, a lab which didn't have their method under control. They repeated the analysis, they found a different result, so we could exclude them. This is an interesting cluster here in yellow. All these 4 labs used the same reference material from one provider for recalibration, and all of them are at the same level more or less, but they are about 30% above the whole average mean. This is a second cluster in green, 1, 2, 3, 4, 5. All these 5 labs used again a same reference material from another provider, of course. Again, the 5 fit well among themselves with about only 3-4% variability, but they are about 12 or 15% higher than the big bunch, let's say. All those in blue have not performed any recalibration or only a minor recalibration. I think this shows very nicely why we need primary or certified reference materials. We want basically to eliminate this kind of clusters that, dependent on which secondary reference material people use, they find different values. So the value assignment was also a critical step, because what do we do with all those data? So we found in the end guidance in the ISO 13362 of how to prepare suitable calibration samples. And this clause specifies in the ISO standard basically that you have to use reference method data to assign a value. They don't even say how many data you need. However, it is mentioned that if you have instrumental data available, and if those two agree within not more than 10%, so if these agree well, in other words, you can combine the data, but the weighing for the reference data needs to be at least 50%. So we decided in the end to assign 2 values, one only from reference data, and one basically which is a merger of, in this case, 14 technically accepted or 13 in the case of the high count material reference data combined with the same amount of 13 routine data. Now, we had 42 routine data sets. We had a few technical outliers. We had 32 of the 42 with no or minor recalibration. So we didn't take into account the other ones because we wanted to be as independent from the past as possible. So only those with either no recalibration or minor recalibration were taken into account with a slope close to 1, in other words. And we randomly picked 14 or 13 from those 32. Seems to be a little bit of a strange approach, but I checked with our statisticians. I also did it 5 times and the result was basically almost the same. So this is basically what you find on the certificate. You find what we have certified. So the property, it's the concentration of cells. We define what we understand under somatic cell count. In the first certified value, it is basically defined in the ISO 13361. In the second case, it is a combined data stemming from both ISO standards. We define in the footnote what a certified value is and what the traceability, very important for a certified reference material, what the traceability is. In this case, it is traceable to the International System of Units. And we also define what the uncertainty is, what it includes, how it has been calculated. And this is written here that we estimated the uncertainty in accordance with the guide to the expression of uncertainty in measurement. So most important for you, I guess, and coming more or less to the end of my presentation, is what do we want to use those materials for? First of all, if you use only the reference method certified value, it's to assess the reference method performance. So you take the material, perform the analysis in your lab, and see whether you find back the certified value. The way how to do exactly is stipulated both in the report and on the certificate. The second point is possibly the most important application of the material. It's the calibration of routine methods. What you could also do, like in under one, you can also assess the routine method performance, doing it exactly the same way. But please don't calibrate and check for method performance in the same instance, because this does not make sense. You can use it to acquire QC charts and see how they evolve over time. You could use them for method validation if you newly set up the method in your laboratory. You could also use them to assign values to secondary or in-house reference materials. Harry will elaborate on this, I presume. And you could use them theoretically, at least for proficiency tests, of course. So that was it from my side. 15 minutes are not a lot. I would like to give some emphasis on our online reference material catalog. We have available about 750 different reference materials from food, feed, clinical, nano, GMOs, BSE test materials from the old days. So a broad portfolio. And this is again the link to the certification report listing everything what I have said on more than 60 pages, so much more detailed information. And if you have any other question, either now or later, you can always contact me by email. And by having said this, I would like to thank quite some institutions and people. First of all, the IDF ICAR project group, to name Sylvia as the first contact point in 2014, but also Harry and Christian over the last 6 years, our processing team, which did a tremendous job on site, and also you, the participants of the characterization study. I think it was I'm doing more than 20 years reference material business now. It was the biggest characterization study I ever did, or I ever organized, let's put it like this. And I also would like to thank institutions which are involved, or which were involved rather, in the feasibility part of the project, where we had to find out how to do things. Actalia, Philippe Trossard, for example, Analytic in Milch. ANSES, at that time till 2017, they were partners in the project as EU Reference Lab, which discontinued unfortunately by the end of 17. I had contact with the Cornell University Department of Food Science, with the Centre de la Recherche Agriculture de Wallonie, that's the Belgium reference lab for the reference method. MCC Vlaanderen, that's the Flemish lab doing millions of analysis 24 hours a day. They did the homogeneity and stability measurements for us. NISO was already contacting the feasibility study phase to find out how we do things. QLIP, QSE, GmbH, and many more. And with that, I would like to thank you for your attention.
Yeah, thank you, Reinhard. Yeah, especially that you gave credit to all these partners, and thank you for keeping the time so perfectly. Instead I would also like to use half a minute to greet Per Cristiano Brazzale, our president in IDF. Hello, I saw you on the list. Good to have you in the meeting.
Hello.
Hello, Per Cristiano.
Thank you. Thank you. Sorry.
Thank you for having us here in the group. And as well, Professor Walter Heschen. He is watching. He is one of the honorary members of IDF and well-known, and I think especially linked to this topic, somatic cell counting. So Professor Heschen, welcome to you as well. And thank you for watching. So Reinhard mentioned, and thank you again, Reinhard, for this work. And so, by the way, you said, okay, it was the biggest study I did in my 20 years career. And indeed, it was not only the work you performed, but the systematic approach and the material we have now. I think it will have large or major implications to many of us. So thank you for your work. And you mentioned the report. I just can advise everybody to go to this report and have a look and really then you will appreciate the work you have done. So thank you again for your work and of course for presenting.
You are very welcome.
So the next speaker is Harry van den Beichert. And I think, Harry, you will refer to how to use this material, and there is a guideline on the way, and you will talk about that in a minute. So it's your floor.
Thank you, Christian. I assume you can hear me now and see my screen. Is that right? Please confirm.
Yes, that's right, Harry.
Okay, thank you. You're right. I will talk to the application of the new certified reference material. And I will also talk about dealing with transition issues when users want to re-anchor their routine somatic cell counting and when they note a significant shift from their current counting level. I indeed will follow the content of a guidance document that we have prepared and that is currently circulating for final approval in IDF and ICAR, which we hope to see published early next year. This guiding paper was prepared by Sylvia, by Werner Lugenbühl from Switzerland and myself. And it will come with an Excel template that can be downloaded from the ICAR website soon. And this template presents not only example calculations with different applications of the CRM, but it will also allow users to make their own calculations with their own data. The new CRM can be regarded as a gold standard in milk somatic cell counting, especially where the reference method, as we know, is lacking robustness and precision. And in that, I agree with Christian, it's a major step forward. And the reference material can be used for the purposes as indicated by Reinhard, and I will go into somewhat more detail with the next slides. The first application I want to touch upon is indeed verifying checks on method performance. A straightforward check on the performance of your method. You can use the material as is after solving it in water. And that can either indeed be a microscopic reference method or it can be a routine method. Important when checking with the reference method, of course, is make sure that the basics are arranged for in a proper way. That means the dimensions of the microscopic field have to be secured. And furthermore, you have to check on your repeatability before you are checking also on the correctness of the values you produce. Guidance for that can be found in the ISO standard 13366 part 1 or the IDF equivalent. In fact, it's a joint standard IDF 148 part 1. When having done that check, it's important to indeed check against the appropriate reference value. When you're examining your microscopic reference method, it's appropriate to check against the listed reference value based on the data from purely the microscopic determinations as outlined by Reinhard and the related uncertainty. But you also may want to have a 1 or a 2 point check on the performance of your routine method. And in most laboratories nowadays, that's flow cytometry. And then the reference values based on the combination of the microscopic measurements and the routine measurements can be your target, including the related uncertainty. And then in the end, of course, it comes down to checking whether the absolute difference you find is less than the expended uncertainty. And for the calculations, I refer you to the guidance document and the template that will soon be available. The next one is on a calibration check. The calibration check that is part of the assurance in reporting correct values when applying a routine method. Routine methods need to be anchored. In other words, results need to be traceable to a reference. And that is where the CRM, the now newly launched EC JRC CRM, or if you wish, a derived secondary reference material, come back later to that. That's where they can help out. If we look at an overview of the calibration procedure that can be presented in a flow chart, and this flow chart shows that also with the routine methods, before doing any calibration check or making adjustment, it's important to make sure that your method is functioning properly. With the routine method, that means your blank checks should be within specs. You carry over, there may be method-specific critical aspects you have to ascertain that you're okay with that. And again, the repeatability and guidance for that is again in an ISO IDF standard. When it's okay, you can proceed. When it's not okay, you have to look into your method or your instrument. But in the end, assuming you arrive at a method that is functioning, that can be proven, then it's time to work on the calibration set. With that calibration set, you can verify your calibration settings. And there is two options. They are okay, they don't need any adjustments, or they are not okay. There's a significant difference, and then there may be need to adjust your calibration settings. For the calibration series, there is two EC JRC CRMs available, a sample low and a sample high. You can reconstitute them in water according to instructions, and it gives you a range between about 60,000 and 1.2 million cells. Some will say I need more cells. What I can suggest in addition to this is then to try to dissolve the CRM powder with in a little bit less water, and then take, of course, the CRM powder with a higher number of cells. I can inform you we did that at QLab, and what we saw is that everything showed linear up to at least 2 million cells per ml. I think this may be relevant for those who work with goat milk. The two samples allow for making a series of at least 5 samples. This is an example with 5 samples, how to mix in different ratios, and to arrive at the sample set with 5 equidistant reference values. And these 5 reference values can be calculated from the ratios in which the two basic materials are mixed. Coming to the calibration check itself, I will now and here not go into the statistics. This can be found in ISO IDF standards like ISO 8196 or IDF 128. And it will also be described in the guidance document with the CRM. But I just want to point out one thing, because if this is not properly handled, you can go wrong in your calibration and your calibration check. And that is what to put on the x-axis and the y-axis. In calibration against the golden standard, the reference values go on the x-axis and the routine method values on the y-axis. So then you do your linear regression and you calculate your values for A and B. And then these calculated values can be checked against the values of A and B with the current calibration. And if there's no significant difference, you can leave your settings as they are, and otherwise you have to adjust. And here you have to be aware that your instrument readout in routine is at the x-axis. Your instrument readout with a slope setting of 1 and an intercept setting of 0, that's on the x-axis, and the result after the slope and intercept correction is always on the y-axis. From a statistical point of view, the result you are reporting, the result on the y-axis, is in fact an estimated somatic cell count. That means going from the left to the right graph, your slope is the reciprocal of B and your intercept is minus A divided by B. So what I want to clearly explain with these two graphs, don't mix up X and Y in calibration or to try to take a shortcut, because you will end up with another erroneous value for slope as well as for the intercept. So just one point to be very cautious and aware about. The next application I want to talk about is assigning reference values to a secondary reference material. First question then is, what is a secondary reference material? Many of you will know, but I just recall by showing you here the hierarchy in my metrological quality control. On the top, you see the SI measurement. That is the basic fundamental measurement of a parameter when available. If not, people have to rely on a reference method or a certified reference material. that is reference material designated or acknowledged as having the highest metrological qualities. Then there is also secondary reference materials. These can be produced locally, but in not only the production, but also in the use, you have to make sure that the material, and especially the values assigned to it, are traceable to the primary standard or certified reference material. And that, how to do that, is listed also in the guidance and in brief summarized here. It's about preparing a material in your own circumstances suitable to serve as a secondary reference material. So it needs to be stable, homogeneous, and be representative for the milk you are analyzing in routine. There's guidance again in an ISO standard, ISO IDF standard. Then you analyze pairwise the CRM and your SRM. That should be samples with about the same cell count levels in enough numbers. And then based on the results you obtain from the average of the pairwise differences and the comparison against the CRM reference value, you can calculate your SRM reference value. The same you can do for the uncertainty. So you arrive at the secondary reference material with both a reference value and an uncertainty. So that about the assignment of reference values to the SRM. Talking about the use in proficiency testing. Again, proficiency testing, what is it? Comparing measurement results between laboratory. That's a very simple definition. And it's an important asset of the EC JRC CRM that it allows to compare, of course, between laboratory. That's possible already in proficiency testing, but it also makes it possible now to compare against the golden standard and compare in time. And our next speaker, Sylvia, will go more into deep about that. Okay, talking about anchoring in somatic cell counting. The PT results Sylvia will present will illustrate, as some data of Reinhard already did, what we also knew from an IDF ICAR questionnaire in 2011. That was one of the early initiatives from the project group. And we wanted to find out at the time, was part of the questions, how laboratories anchor their routine counting. And that resulted in a diverse picture, so to say. So some applied indeed various secondary reference material, but there were more than 20 suppliers worldwide, each with their own reference values. A number of laboratories also relied on the manufacturer settings with the instrument and the checks through proficiency testing, or adjusted their calibrations based on the results in proficiency testing. So in fact, somatic cell counting was and is in fact still a big ship sailing with many anchors. And talking about this, this is not about who is right or who is wrong. All is probably defendable in light of applicable regulations or an agreement between local stakeholders or good laboratory practice principles. At the same time, the consequence is that there are considerable differences in counting around the globe. And that touches on the principles of fairness and creating and maintaining a level playing field. And those aspects are quite relevant as goods travel across borders, where many dairy companies collect and pay raw milk in more than one geography, and where breeding values are compared internationally. And now with the EC CRM material, there is an excellent opportunity indeed to get better harmonized in this and to find much more equivalency in milk somatic cell counting. But it also means that there is need for re-anchoring in some geographies. And that may come with a shift. And that is what the last slides are on. Where such a shift is insignificant, so not significant, like in Bavaria, I understand from Christian, then it's a matter of fine-tuning, which can simply be left to the labs and the providers of the secondary reference materials. But with a bigger shift, it is appropriate to sit together. It's also wise to sit together then. And then the stakeholders have to think what representatives should be involved, about informing them, about the background of the situation, and about the solution that is now available. And there's a number of aspects to consider. Aspects such as what is the expected shift in the count, and that can be determined by running a CRM calibration series under your current settings in routine and compare to the assigned reference values. So that is determining how big the shift is. You can also look at your proficiency testing and compare. Are there consequences for limits in case you are re-anchoring? Do they need adjustment? Can they be adjusted? You need to make sure that you secure your interlinkage between past data and new data. That means that you have to clearly document how big the shift is and keep that archived. Are there protocols to be changed? That is all to be considered when you are entering in such a situation. And then if you go for re-anchoring, it's important to think about the timing of the transition. When do you change? Will you do it in one step, or do you need multiple steps? Although with multiple steps, there will be more and longer arousal probably. And it's important, of course, to think about communication. To who, when, what, and how. And in this, there's unluckily no recipe that fits all, because situations are different. You need to re-anchor, in possible regulatory hurdles, in structures, in required actions to change. But these are, from my perspective, the points of attention. And I think IDF and ICAR will be most happy to assist you with advice and offer a platform to share experiences. This contemplation on a re-anchoring is underway in a number of countries in Europe and elsewhere. Some have already re-anchored, and stakeholders in other countries have indicated their intention to do so in the nearby future. And of course, everybody is curious about what others will do. And here I want to stress to all, there is now a robust opportunity to harmonize. So I warmly encourage you all to see whether in your geography you can link to this new anchor for better global equivalence in somatic cell counting in milk. And that brings me to my last slide, indicating that this was a long and winding road, but I want to thank all who contributed in and outside the IDF ICAR project group, and thank you for your attention. Thank you.
Yeah, Harry, thank you as well for perfectly keeping your time. And I just can reiterate, it's not a question of right or wrong. It's a question of collaboration, of course, and how to do the things step by step in the future. But before we go on, I have another very nice duty to welcome the new ICAR president, Daniel Lefebvre. I saw you are also on the board, so we have two new presidents of our organizations, and this is distinguishing our small webinar. So welcome to you as well.
Good afternoon, everyone. Thank you for participating in this webinar.
Thank you. So let's come to the last part, and Harry perfectly set the scene for the next step, what to do. And I think one of those steps are already made. And Sylvia, you will report about an application, so to say, and the outcome of the ICAR ring trial or proficiency testing. So it's your floor, please.
Thank you, Christian, for giving to ICAR the possibility to share this experience. That just a moment, let me try to put on this. Okay, my presentation is on the screen now. Hello.
Yep.
Is on the screen.
Yep.
My presentation. Okay.
Now, yes.
Yeah. Okay. So thank you, and thank you also to all the participants. I have to say that it's really impressive how many colleagues are we met each other. So this is really a new experience of how to interact each other. So I hope that this experience and this application can be useful to see how these new tools can be implemented in the real life. So since 2016, ICAR is providing an accredited proficiency testing scheme. And what is nice to see in this map that we have 88 participants, but what is important that these participants came from 40 countries and four continents. So it means that we have in this proficiency test scheme different analytical setting, let's say in this way, different instrument adjustment, different secondary reference material use, and different anchoring, as Harry said in the previous presentation. These are the parameters offered in the ICAR proficiency testing scheme, and for the topic of this presentation, we will focus on the somatic cell counting. For the somatic cell counting, we have, this is the distribution that we have, all the continents are represented. So we have from Japan to Argentina, to Chile, to Northern America, to the European countries, a lot of them, of course, but also in South Africa. So it's really well represented. We are looking forward to include also Australia and New Zealand. We are still waiting for them. What we do in the ICAR PT, besides to provide to each participant an own single performance report, for ICAR purposes is also important to follow over the time the precision of the method. And for somatic cell counting, 90% of the participants participate with the fluoro-optoelectronic method. We have only 1 or 2 labs that sometimes apply with the microscope, and 1 lab participate with the charger couple device. So the figure, the precision that you see on the slide, it's really the precision of the fluoro-optoelectronic method. And for this method, standardized method, we have fixed an overall standard deviation of repeatability in the relevant ISO standard. And you can see the blue dot, that is the standard deviation of repeatability, is lower than the ISO IDF limit. At the contrary, the standard deviation of reproducibility, that each spot represents a PT round, is always above the 10% fixed. So this can be also represented by the distribution of the labs that we have. On x-axis, if we put the distance, the bias between the mean lab and the mean of the assigned values of the ICAR PT sample, and on y-axis, we put the standard deviation of the difference for each lab, we have this distribution. We can follow this distribution over the time. So starting from 2017, if we go ahead in the time, it's good to see that we are increasing the number of participants, and we are happy as the ICAR PT organizer. But what is not good is that the distribution is continuously to be the same. It's really static situation. You can always see that we have 2 branches of distribution, one underestimating and another overestimate. And a group of labs, they are centralizing plus minus 10%. So this situation doesn't change over the time, as also already demonstrated Rainer Zeleny during the characterization process. This is mainly due to the type of calibration setting and the type of the secondary reference material used. So if, for example, we take the last PT round and each dot, instead to be represented by the blue color, we represent each dot with the color of the secondary reference material used, we can see that usually the same reference material used, with some exception, but this is other technical issue, are grouped in the same area of the distribution. You can see here we have the same reference material. These 2 labs use the same reference material, and we are in the same box. So we have 5 secondary reference material that are in the green box. So for them, they are quite aligned in terms of the traceability to the assigned values of the ICAR proficiency testing scheme. And these 5 secondary reference material producers are located in 5 different countries from 3 different continents. And this, for me, I think that it's a very good information. So we have 5 secondary reference material that more or less are aligned each other, and already they are distributed in 3 different continents. So it's a very positive message that we received from our data. Doing that, we decided in September 2020, thanks to the availability of the gold standard, the certified reference material provided by the JRC, we decided to try to build up a linkage between the ICAR PT and the golden standard. For the next slide, please have in mind these two definitions. As assigned values, I mean the statistical values that we assign in the ICAR proficiency testing scheme, and with assigned values traceable to the gold standard is the values that we have calculated in the way that I'm going to illustrate to you. This report is published on the ICAR website, so you can download for further reading. Following the flow chart that is reported in the guideline that Harry just illustrated in the previous presentation, we checked the two instrument functioning. Thanks to the collaboration with the proofing buyer, we have done our normal quality assurance checking, as illustrated by Harry before. Some of them will be done using also the certified reference material that we prepared according to the protocol, but of course, for different purposes, other dilution ratio can be prepared. The important that you have always the lower and the higher level they are certified, and you can calculate your intermediate values. We check the repeatability and the linearity of these two electronic instrument. Furthermore, we check it for each instrument if they were compliant with the expanded uncertainty. For each sample, we have done this check, and you can see that everything was compliant. Also, we checked the distribution of the regression line and it was okay. And also we applied the statistical check that are described in the guidance that is going to be published. I will not go in statistical details, just I would like to assure you that beside this guideline, you will have an Excel file where you can input your data. So inputting your data, you receive the results and you will receive the answer to the question, is the instrument adjustment necessary? No, in that case, for example, or yes, in this case. So of course, I'm looking forward that all of you go in detail of the statistical formula, but if you are not very familiar with them, you can use the Excel file, and the Excel file will give you all the information you need to adjust your calibration setting of your instrument. So now we have this, the distribution. This is the normal picture that we obtain in our ICAR proficiency testing scheme. Using these two calibrated instruments with the gold standard, we calculated the assigned values traceable with the gold standard. And you can see that this is only 2.5% lower than the assigned values that we have in the ICAR PT. 2.5% is not a big values. I mean, it's not important, so big impacting values. But what also we have to consider that the distribution is not very well concentrated. So we have too much variance between the participants. So the expectation, if this certified reference material will be implemented in the future, is that this green box will move a little bit down, and the future distribution will become always closer and closer to in our green box. So this should be not a dream, should be a real life solution if all the hurdles that listed Harry before will be solved in the coming months and years. I really would like to show you this slide. This was prepared in 2010 for a presentation of the JRC celebration laboratory, 10 years of the lab. And just to remind you, the approach that we use to develop this reference system for somatic cell counting. The fact that nowadays we have a golden standard, it's for sure a milestone, but this was the results, really important results of the bottom-up approach that always we used during this project. What I mean as a bottom-up approach, we consulted and we organize around the table of the reference system for somatic cell counting standard organization, metrological institute, milk labs, DHI labs, but also labs that in the same time performs also milk payment, producer of secondary reference material that have a really key role in building this traceable chain. Instrument manufacturer also is important to collaborate with them, research center, university, governmental and non-governmental organization. If you see on this logo, you can see many European organizations, United States organization, New Zealand, DHI organization from different parts of the world. So really we tried through the conference, advertising on the website with publication questionnaire, as it was mentioned, the newsletter, they are still published on the IDF and ICAR website to disseminate the output and the information that we collected in building up this project. As any good goal, and this is the golden standard we have nowadays available, it's really necessary to monitor how it is implemented in the, is implemented in the future. And ICAR has the task and will continue to follow the ICAR PT participants. They have to report in the result sheet the type of reference material, secondary reference material they use. We will maintain a contact with the secondary reference material and to see how they are going to implement the traceability with the gold standard. And in the coming PT reports, we will provide also a summary of the ICAR PT performance linked with the golden standard. So we will use this indirectly way to be connected with the golden standard. Only 2 weeks ago, also, IOS and Chemstat received from Metrofood and Food Cloud demonstrator the possibility and the task to organize a pilot calculation model that will monitor not only the laboratory performance and will assign to the labs a quality index, but also the proficiency testing scheme. Because we know that despite the PT are accredited or are recognized worldwide, the performance between them is different. So we will apply this calculation model to compare the different proficiency testing scheme. So any of you are interested in participate to this calculation model, please contact ICAR Secretariat or myself, Silvia at ICAR.org, and you will be more than welcome to participate in this calculation model. So I really would like to thank all the groups of the reference system for somatic cell counting that really dedicate a lot of time, efforts, expertise in these 11 years at least. But as Christian said, we're starting to speak about this project in 2005. And all the organizations that participated in this last test of a PT scheme that made available the traceability to the golden standard. And I would like to thank all of you and stay linked with us and promote the analytical equivalence for somatic cell counting. Thank you.
Yeah, Silvia, thank you very much for this excellent presentation, and you explained how we can do hands-on converting all this knowledge and we have now into practical use. And I think this is also the time beside Reinhard Seleni, you, I have to thank Werner Luginbühl and also Thomas Berger for the statistical background of that. And Silvia, you are really the one performing that, and it will be a hands-on model how you can really use in the lab. And I think this is extraordinarily positive and useful for all of us in the labs who are not as familiar with the statistics. And so it's really in all overall, it's a huge achievement, I think. So we are ending at 4 o'clock sharp. And of course, there's still the option to put some questions forward for you as attendants. So in case you have one immediate and urgent question, please go ahead and use the chat function. There is a question if the slides will be distributed. I can say yes. We will publish in due time on the ICAR and IDF website as a PDF version. There's another question. What is the recommendation to carry out this transition in case of detecting a large significant deviation of results? I think this is a point Harry referred to. What to do if you realize that your present status is quite far away from the golden standard. What would you answer?
Yeah, that's indeed something I addressed in my presentation, but not coming up with a conclusive answer that fits in your situation, because we do not have enough knowledge of individual situation. So I think it's important there to consult with the stakeholders that are involved. And if we are talking here about payment testing, then you have to deal with regulatory and supervising bodies in your country. And I think it's wise to start with them, to inform them about the situation, what opportunity there is, especially countries which have traveling goods across borders. Goods still do, people don't in COVID times, but goods do. Then you must really consider in fitting the levels together. And then, of course, it's a question what is necessary for that, but also what is the best timing, and that has to be concluded upon. What's the best timing? Do you need some time to prepare your communications? You're changing protocols properly, take that time, because there's nothing worse than doing it not well prepared and getting into trouble afterwards with people complaining because of not being informed, etc. So it's important to prepare it properly, and then in that also consider whether you go in 1 and 2 steps. If the difference is big, you can consider going in 2 steps, but it will extend the time that you are in the focus. So if it's possible, I would advise going 1 step.
Thank you, Harry. I may mention that we were talking to competent authorities in the US and New Zealand before, just by chance of attending conferences there. And I would assume that you would be ready to join, not to join, but to support such questions if there is a specific discussion in the country, and to support with your experience in how to tackle these questions. Am I right?
Yes, you're right. I'm willing to do that, but I also want to include then people also working in that geography and also were involved in the project, because we had good representation in the project group from many countries, and I think most of the continents. So I think it's important that we cooperate there in our guidance how to best achieve the transition wished for.
So my message would be, don't feel being alone. If you have such a situation, come back to us, to Harry, to the group members, and we will assist you in supporting you.
Yeah.
May I add a small observation of that? Could be interesting, and I think that is useful for the organization. They are a little bit hesitant to starting the process, just to try to do some tests to obtain the parameter, the statistical parameter following this guideline, and they can to step back and to recalculate the data they obtain, for example, in the last 2-3 months, and they can show to the different organizations what it is nowadays and what it could be tomorrow if they move. And based on these results, they can decide the strategy. So they can do virtually from the first time.
Yeah, I think this is as well helpful. Thank you, Sylvia.
Christian, may I bring in one question that was asked before in the mail? Maybe you remember. There was a question posed before on what countries have already re-anchored or are planning to re-anchor. It's a question in general. Maybe it's too blunt to ask, but it was a question in the mail before.
No, I nearly forgot. As you mentioned, for us in Bavaria, and this is linked to the German situation, I can say we are lucky enough that we are quite in the center of the target value of this material. So for us, luckily, we don't have to think about changing the level. I know, of course, from neighbor countries, from France, as well as from your country and others, that there is a slight difference. And as you laid out, there should be a strategy how to go forward with that. And of course, I think it's also a new topic for many competent authorities, because if you come from the regulation side, you set a threshold and procedure how to deal with the values. But yeah, this situation that we have some differences on a worldwide scale as well as in Europe, I think it was not recognized in a sufficient way so far. But I think now this is a scientific base. And as you mentioned, it's not about right or wrong. It's about how to level this playing field and to really use the scientific knowledge we have now to adjust and to step forward into this harmonized situation we all intend to have. And so as far as I know, there is not an official table of countries where they are and what they intend to do. But I recognize from some phone calls I got during the last 2 weeks that there are some questions in different countries. And I think this will maybe also trigger the webinar we had today, trigger the discussion about that. And I'm sure during the next months, we will have more of that questions on the table. And I guess there are some answers for that. I don't know if this answers the question. So far as I know, we don't know what countries of the EU are implementing the new material when and how. So it's just the personal communication I have. But as far as I know, also we are very unlucky that the European reference lab is no longer working in our field. So this would have been a task for this colleagues in the lab in France. But so far, I don't know. I'm not aware of an infrastructure in the EU dealing with this question now. And maybe there's also in the near future communication about that.
Yeah, maybe Christian, then I have a question for Reinhard. Maybe he can indicate what is the route for something like that in the nowadays EC. Can he answer to that, or is it too complicated a question for him?
The question is very simple. The answer is possibly somewhat more complicated. No, but it's too far away from my personal field. So we are not in the legislative sector. We are basically policy advice and policy support. What we certainly cannot do as commission is to, and certainly not as JRC and certainly not as unit, is to force people to use this reference material. We can only recommend to use it. Our intention was to put this on a broad basis, to have many countries and continents contributing to this, and not to give the impression that this is a EU type of thing which is not accepted elsewhere. That was not the intention. Put it on a broad basis, work scientifically, technically as good as possible, and then basically let the market decide.
Maybe I can put it in that way. I see it, the webinar of today, as a multiplying platform. So we had partly more than 120 colleagues joining this session. And I think the message is out there. And yeah, during the next weeks and months. Hopefully, this will be discussed more in detail. And as you, three presenters showed, we have the tools to tackle this situation and to move forward in a practical way. And I think this is really a good summary of the presentations of today, to give you the information and also the feeling that now we are, I will say, you are coated with the necessary tools to go forward. And we were not 10 years ago. And I think this is the positive message of this webinar. I don't see any questions in the chat, so maybe I give you another 20 seconds. And of course, we are taking the congratulations from some participants. We are very happy for that. Thank you for this. And I want to greet as well all the members of our joint action team of the reference system for somatic cell counting who were present today. And as Sylvia and Harry did, and also Reinhard, thank you very much for the contribution and all the assistance over many, many years of this work. I think together now we can harvest the fruits of this slow growing tree. But in the end, I think the fruits will ripen and we will be able to enjoy them. Okay, so I see Pier Cristiano wants to address us, so I give the floor to Mr.
One
President.
minute. One minute.
Of course, no problem.
I want to thank you for the organization of this very interesting webinar. Thank you to you, Christian, to Harry, to Sylvia, and all the other speakers. Very interesting. I hope to increase the collaboration with ICAR, and I would like to meet as soon as possible Daniel for to meet and to discuss the next cooperation between IDF and ICAR. Okay. Congratulations, and thank you, because it's really essential and very important for us to have these webinars.
Pier Cristiano, thank you for your words and to be with us. It was really an honor for us, I think, for the whole group. And I see Daniel as well speaking up. Daniel, please.
Well, I can only echo Pier Cristiano's comments to everyone that was involved in developing this very important development for our members and for the industry. And thank you for setting up this webinar today, and for all of those that took part.
Okay, thank you as well for spending your time with us. I think it's a great honor to have both presidents with us in our working group. With that saying, I want to thank you all participants. As I said, more than 120 were with us today. Thank you for listening, and hopefully we'll see each other again soon, not only via our video conference system, but also in person. So thank you. Have a good afternoon or whatever time it is in your country, and stay well. Bye-bye.
Thank you. Bye-bye.
Bye. Thank you, everybody.
Bye-bye.